What's up, everybody? How you guys doing? I'm terrible. Thanks for asking. This week, we have a fun little project from a company called MIOYOOW? MIOYOOW. It's called MIOYOOW. Its name is MIOYOOW. And from the looks of this one, it seems like their products are pretty okay. Hey man, that's high praise from the Let's Make Shit guy. So let's get right into it. Let's make sure everything's here, and as always, here's a breakdown of the tools we're going to use. Well, as usual, this kit came from Amazon at a cost of $19.99, so about the price of a dozen eggs in 2025. I have to admit, the instructions, while minimal, are in-depth enough. I never found myself wondering what language I was reading, or what to do next. So hats off to you, MIOYOOW, plus one shit out of the box. So this little guy is a KT148A-8 voice chip, and its job is to store up to 420 seconds of audio, and it can directly drive a half a watt speaker. This chip already comes programmed with a song in it, but if you have the equipment, it looks like it could be easily erased and new audio added. This is a little bit above my pay grade for now, but I can already think of a bunch of fun use cases for this. A tiny speaker, a 5-volt battery, some hot glue, a cap or two. Place this chip strategically in somebody's bedroom. Hilarity will ensue. Next up, we have the lone 47 ohm resistor, 2 0.1 UF ceramic caps, and a 22 UF at 16 volt electrolytic cap. Hey, and don't forget to check your polarity if you're following along. The side with the white stripe is the negative. Hey, this PCB is marked with a plus and a minus. Nice. Plus half a shit. So the resistor looks like it's for the motor circuit. I don't know for sure as there's no diagram. I think I'm taking back that half a shit. The 2 ceramic caps are for the audio circuit, and the 22 UF cap is for what looks to be voltage smoothing on the power rails. Looks like this is going to be one hell of an easy build. Oh wow, I'm moving fast here. Hey, now we have the potentiometer, the barrel jack, and 2 toggle switches. The barrel jack is for, well, I'll let you figure that out. The pot is working as a speed controller for the motor. It works by limiting the voltage to the motor. Turn it to the left, less voltage, hence less speed. All the way to the right, full speed ahead, cowboy. And the switches? Well, they're switches. One controls the motor and the other the audio. Now for something a little bit more challenging. These screws, man. Well, for one, it looks like I'm either losing my hand dexterity, or my eyes are finally failing me. Because getting these washers on was quite the bitch. As for what they're being used for, well, if you thought it was to hold the motor on like I originally did, you'd be wrong, just like I was. They're actually being used at what I'm guessing is a rudimentary slip ring assembly. More on that in a few. So getting these soldered in was quite a challenge. You see, while I really like this soldering iron, for anything with a large thermal mass, say a screw for instance, yeah, not so much.
You sure about that?
So let me introduce to you my old friend, Uncle Bill, affectionately known as the I ain't playing around no more gun. I've had this thing for years. It's an old school soldering gun, probably from Harbor Freight, and probably cheap AF. This thing is 180 watts, so twice as powerful as the 101. I haven't used it in a very long time, so let's clean the tip and get this done. Wow, now that I'm watching this back, this thing is taking forever to heat up. That should have been my first clue. The problem with these things is that you have to hold down the trigger for it to work. Yeah, I know, first world problems. I kind of remember this being faster, but it's been so long, I don't know. Now remember, I speed most of these clips up, otherwise we'd be here for hours. I mean, I can't even get most folks to watch for 3 minutes, so. But I was holding that trigger down for like 3 minutes. Something was definitely wrong. So while you watch me fiddle with this, which is probably a 10 to 15 year old soldering gun that's probably just no good anymore, this is the part where I ask you, dear viewer, to consider subscribing to the channel. I mean, hey, you've already made it this far into the video. Why not? Hook a brother up, man. I'm almost at that 500 mark. Make a bitter Gen Xer prove his parents wrong when they told him, no one cares what you have to say, asshole. Just get a job and be quiet. True story. And hey, while you're at it, what do you guys want to see me make next? Someone a while back suggested a vacuum tube audio amp. And that's on the horizon, as they say. How about I do it this way? Here's 3 items. Pick one and leave your choice in the comments. Maybe I'll figure out a way how to make a poll in the comments. Oh wait, you need 500 subs for that. Come on, man, even more reason to sub. Well, I gave up on Uncle Bill after that. I guess I still was playing around. But what I did learn is the TS-101 is powerful enough. If you're patient. Or if you preheat the board. One or the other. Either or. 6 in 1. You get it. I mean, the back heated up pretty quick. Oh well, live and learn. I guess that's why the TS-101 comes with a boost mode. Boost up the temperature, stupid. Works every time. And yeah, I bought a $60 Harbor Freight air compressor, so what? It sucks. Don't bother. This is all it's good for. Blowing stuff. Yeah, no more That's What She Said clips. It's getting old. Let's give this board a nice cleaning. As usual, let's hit it with some 99% isopropyl alcohol and scrub it down. You know, I've been thinking about getting an ultrasonic cleaner. Can anyone out there recommend one? I mean, I'm not looking to break the bank. Sub $100 would be nice. Everything I find on Amazon looks like crap. Any suggestions? Please hit me up in the comments. Let's move on to the motor. A motor. I don't think I've ever used it for a project on the channel before. So, it's a motor. It's 5 volts DC. You screw it onto the plate with nuts and bolts. I mean, it's a motor. You put voltage to it and it spins. But how, you ask? Well, fine, I'll tell you. Jesus, you don't gotta be pushy. You know what's weird? Sometimes I know how things work. Like a motor. I mean, I've been fixing them for a quarter of a century. But this is where my poor grasp of the English language comes in. Like, I can picture it working in my head, but explaining it? I'll try to explain it like I see it in my head. Let's try that. So you hit the power switch, or give it batteries, or whatever, sending the required voltage to the motor. In this case, 5 volts. The electricity flows through the coils of wire that are attached to the rotor. The rotor, or armature, is attached to the shaft, the part that spins. You know, you get me. So when the power is flowing through the coils of wire, they create a magnetic field, either north or south, depending on the polarity. Then you have the commutator. This is what switches the polarity of the magnetic field by changing the direction of the current. So north-south, south-north, every half a spin or so. Now the casing of the motor has permanent magnets attached inside. So, you insert the rotor into the case, like a tube in a tube, so to say, and the magnetic field, once the power is applied, do their push-pull thing, and boom, the shaft spins. I mean, there's a lot more to it, but that's the basics as it was taught to me in the late 20th century. As for the speed control, well, that's where the pot comes in. It turns up or down the current flow. Lower flow, weaker field, slower rotation. Higher flow, stronger field. Full speed ahead, cowboy. Yeah, I know, shit explanation. Hopefully you kinda get it. Oh yeah, and motors are of course polarity sensitive. This one has a black wire for the negative and a red for the positive. And the board is marked. Again, nice job, Meow. But if we were to reverse them, it'll just spin the opposite way. Going in now are just some brass standoffs. They're going to space out the PCBs from each other. It's a nut and a bolt, basically. Then moving on from there is the speaker. It's your basic 1-watt speaker. Again, it's polarity sensitive, black and red wires. For the most part, if you get it wrong, it'll still work. It's just going to sound like shit. In this application, probably wouldn't even notice it if you got it backwards anyway. Yeah, I know, stripping wires with side cutters. Get out the cross. Someone's going to be like, come on, bro, you're going to cut into the wires. Use the correct tool. And to them I say, you're right, I'm lazy. But if it works, it works. I've been stripping wires long enough I could do it with a Phillips screwdriver. I'd prove it, but again, lazy. Actually, screw it. Here you go. So these springs, they're the other half of the slip ring assembly. We're going to slip them over the screws from before and solder them onto the board. I'm just holding them down with the tweezers so they don't move. You'll see in a minute or two that they ride, or maybe glide is a better word, on the next PCB in the stack. This allows power to be transferred to the lights on the top of the kit. This is kind of a ghetto way to do this. They could have used a brush system, but hey, it's $20 and this will work. Look at that, TS101 did those joints like a champ. I don't know what happened the last time. That was weird. Okay, let's move on to the next PCB in the stack, and now we can see what those springs are actually coming in contact with. Again, doing it this way, they're going to wear out probably pretty quickly, but I have a fix for that later on. Let's secure the motor shaft down to the PCB with that screw, add another set of standoffs, and then I'm going to skip ahead to the top PCB so I can solder all those RGB LEDs in. So at first, I thought bending these LEDs with tweezers would be a good idea, but just inserting them into the board and bending them over was the best way. Technically, they're supposed to dangle. Dangle. That's a fun word to say. They're supposed to hang down vertically, but oops, oh well, I know for next time. These are RGB LEDs, and oddly enough, there's only 2 pins. Now for the life of me, I couldn't figure out how they were running through all the different colors. This thing doesn't have a microcontroller for them. So just how in the hell did they flash? Hindsight and all, the fact that they only had 2 pins should have been the giveaway. You see, they actually do have a microcontroller. It's just super tiny and inside the LED itself. I mean, for real, the controller has to be like a millimeter or smaller. I mean, it's tiny.
That's what she said. Or he said.
Yeah, I lied. I'll never stop using that clip. Remember now, LEDs are polarity sensitive. Short pin is the negative, long pin is the positive. So how you like that flip trick? Those LEDs ain't falling out on me this time. This PCB is not marked. Well, it is with the circle and the square gimmick, but I never remember which is which. Another half a shit deduction. Everything else was clearly marked. You did such a good job so far, MIOYOOW. Oh well, everything falls apart in the end, huh? And now, for fun with magnets. When cutting the excess leads off, just hold the magnet close, and well, I think you can see how it works. Of course, you could just cut it over a box. One's easy, one's fun. I'll let you decide. Now, for the horses themselves, these are a little tricky to solder, as there's no stop. They just slide all the way in. I guess my best advice is to tin all the pads first, and then just do your best to hold them straight. And at an even height. You could also just put a piece of tape across the back, blocking it from going all the way through, but I didn't think of that till right now. Hindsight! As for soldering them to the board, just push the solder in after it melts onto the pole. Worked for me. Then, after they're all caught, hit them with some extra solder. Actually, it is pretty easy. And do the same for the other side. And would you look at that, another kit in the books. For power, this uses a barrel jack to USB-A cable. Actually, kind of improvement from the EDAB kits. Those come with nothing. So let's get this thing plugged in and, one LED is out. Oh well, no perfection for me. But it does look like everything else is working. Carousel is spinning, speed control is working, as are the switches. Go me. Easy fix for the LED, just hit it again with good old Jeremy irons. And we're done. Now you can't hear it because I need tunes on when I'm working, so I record the audio after the fact, like you couldn't tell. But those springs gliding across the plate are super loud and super annoying, especially at higher speeds. So what's one to do? Well, what you do is, you order electrically conductive grease from Amazon. ECG, as I will affectionately call it from now on, is basically just grease with metal or graphite in it, allowing for power to flow through the grease and onto the plate. Then you take the entire thing apart again, use too much grease the first time so that it spreads and shorts the positive to the negative, clean it off, and then follow the directions about applying a very thin layer. Who knew directions were actually useful? And now we have a quiet split ring assembly that won't wear out those contacts as fast. Science! And now it actually works. And it sounds much better. No more scraping. Well, it is noticeable at higher speeds, but nothing like it was before. Nails on a chalkboard, man. Nice job, Let's Make Shit guy. Well, as for a rating, let's do the math. Start out with 0 shits, +1 for the decent instructions, +1 for the fun factor. It is kind of cute even though it's super simple. Plus a half for, well, most of it having the boards marked with a plus and a minus. Let's give it a +2 for ease of assembly. This will be a great kit to do with a kid as their first kit. It'll fill an hour or two. Nice quality time to teach them, or learn something if you're doing it yourself. And a final half a shit for the price. At $20, it's not exactly cheap, but it's not crazy. Now the negatives. -1/2, no diagram. -1/2, no marks on the LEDs. And another -1/2 for, honestly, it should come with a little packet of grease. So for a final tally, 3.5 shits. Hey, that's high praise from me. I mean, honestly, almost nothing should get a 5 shit rating, unless it's life-changing. And with that, I'm out of here. Here's some B-roll, and as always, thanks for watching.